Dear students, now in this video we'll discuss about the image formation by the spherical lenses. First of all, we'll see the image formation by the convex and then by the concave. So when we place the object at different places, we get the image at the different places. See, I'm taking all the cases one by one. See the first case, when the object is placed at infinity. Infinity means unmeasurable, a very long distance, like the sun is placed from the earth. So when the object is placed at the infinity, rays always come parallel to the principal axis. Okay, always, if the object is at infinity. So according to rule, as discussed in the last video, the rays will pass after refraction through the focus. So image will be formed at the focus, and the size very small image will be formed here. So you can say, because the rays are really intersecting to each other, so you can say real inverted and diminished, very diminished. Diminished means very small. Diminished image at the focus will be formed. Okay, image will be formed at the focus, highly diminished. Now the second case, when the object is placed beyond 2f. Okay, at any place you can take here. Suppose beyond 2f I'm taking, so beyond 2 you can take. Always in all the cases you have to take the first ray parallel to the principal axis like this, and it will pass through the focus after refraction like this. Okay, show always arrow also. Okay, and the second ray you may pass from the optical center. Okay, it is the f2f1, it is a 2f2. So if you make this diagram carefully, you will find the object image will be formed between the f2 and 2f2, that is the between f and 2f. So real, again it is the real image. So real inverted, and it is smaller also. Diminished image, smaller image between f and 2f will form. Okay, in this case make the arrow also. Is it clear, dear students? Now see the third case, when the object is placed exactly at the 2f. When you keep the at 2f, so see the image, how the image will be formed. Show the first ray parallel to the principal axis. Okay, it will pass from the focus. This is the focus. Okay, like this. Okay, and show the second ray from the focus, from the optical center, like this. Okay, from the optical center, and yeah, it is like this. Okay, here it is cutting. So you will find the image exactly at 2f. Okay, so image will be formed exactly 2f at the same position as in the case of the mirrors. Okay, so real inverted, same size as in case of the mirror, same size at 2f. Okay, image will be formed. Okay, see the next case, when the object is placed at f, between 2f and f. Okay, suppose in between you are showing like this. This is the object. Then show the first ray parallel to the principal axis, which will pass through the focus like this. Okay, and show the second through the optical center. Okay, this is the ray, and the image, it is beyond 2f. C means twice of the focal length. So in this case, in fourth case, image real inverted and larger image. Image is larger in comparison of this one. Larger image at, you can say, beyond 2f. Okay, beyond 2f always, and it is larger in comparison of this one. See the next case, when the object is placed at f. I am putting this at f. See in this case, it's an interesting case. What will happen? First ray will pass through the focus after refraction like this. Okay, and second ray like this from the optical center, and you can see these two rays are parallel to each other. These two rays are parallel to each other. In that case, it will meet at the focus. So these refracted rays, two rays, will meet at the infinity. So because we are assuming they are meeting, it means the real inverted image, real inverted and highly large, like the sun. Okay, when the sun is at infinity, it's a smaller image forms at the focus. Now the smaller object is here, so big image will form at the infinity. So larger image, highly larger image at infinity will be formed. Clear? Now see the another case, when the object is placed between F and O. Okay, like this. Okay, show the first ray here like this. It will pass from the focus. Okay, and second ray. Okay, so these are diverging like this. So they will not meet this side. So what we will do here? So just join both on the other side. Okay, other side like this, and here also. So this point you can see a larger virtual and larger image will be formed at the same side of the lens. Is it clear? Okay, because they are not meeting this side, so you can join them at this point, this side. So virtual and erect. This is the erect image, and erect and enlarged image will form at the same side of lens. So these are the 1, 2, 3, 4, 5, 6 cases. Okay, 1, 2, 3, 4, 5, 6 cases. So just practice all these because it's very important for your exam. Now come to the image formation by the concave lens. There are only two cases, as we had discussed in case of the mirror, convex mirror. Here it is in case of the concave lens. So first, when the object is placed at infinity. Okay, so here object is at infinity. Okay, so rays will appear coming from the focus. It is the after refraction. So image will be formed at the focus, highly diminished. So at focus, image will be formed at focus, highly diminished. highly diminished. Okay, see the another case when the object, and it is, see, it is a virtual and erect also. In both cases, both cases virtual and erect image, in both cases. Okay, first case and the second case, first and second both cases, images were always virtual and erect. See the second case when the object is placed anywhere except the infinity. Okay, first ray, so it will appear coming from the focus like this, pass the second ray from the optical center, so at the intersection of these two lines, image will be formed here, a smaller image. Okay, so this is the image. So you can say diminished image between F and O. This is the optical center O. Clear? This is the optical center O. This is the F. So between these two, image is always formed erect, virtual, and between F and O, image will be formed here. Okay, so these are the image formation by the concave and the convex lenses. Now we can discuss some more points about the lenses. See, sign convention, we can discuss about the sign convention. Already we know all the sign conventions in case of the mirrors, that is measurement of U, V and the F or 2F. So follow all the same rules. Okay, when it is positive and negative, and what is the rules for the H and H dash, that is the height of the object and the height of the image. Okay, rules are same, there is no change. And more important thing for you, which is new for you, that is the lens formula. See what is the lens formula, which is we had to apply sign convention also in the lens formula. Lens formula is given by 1 upon V minus 1 upon U is equal to 1 upon F. Okay, remember this. This is the lens formula. And what was the mirror formula? In mirror formula, it was the positive. It was the positive here between. Okay, another formula you have to remember for the numerical magnification. If you remember, magnification in mirror or the same, it is the same almost. So magnification of the lens is defined as the height of image to the height of object, that is the H dash upon H. This is the formula, and it is related to the V and U also. So we can write M is equal to H dash upon H, and it is equal to V upon U, related to the image distance to the object distance. Remember, in case of the mirror, it was with negative sign here, but here it is positive sign. Remember, it is negative, so keep here positive. In mirror formula was here positive, so in the magnification it was here negative. So here keep the positive. Remember, okay, don't forget it. Dear students, one more topic about the lenses we should aware about it, that is about the power of lens. Power of lens. Okay, power of lens. You know, when the ray passes from the lens, it converges. So diverging or the converging or the deviation of the ray of light is the efficiency or the capability of a lens. So if its efficiency increases, its power increases, then what will happen? It will converge more. It means in that case focal length will decrease. If the efficiency, its power becomes less, in that case what will happen? The focal length will now increase. So by increasing the power, focal length decrease, and by decreasing the power, the focal length increases. That is, you can say the power of a lens is defined as the reciprocal of the focal length. Okay, so it is the reciprocal of focal length. Okay, if the focal length is in meter, so its unit is diopter, denoted by capital D. Is it clear? Its unit. But here focal length should be in meter. Okay, if it is in meter. Okay, or if focal length is in centimeter, you can write it is 100 upon f. So remember this formula. Is it clear? I think. And the power, suppose there are so many power lenses you have, so combined power is always algebraic sum. Algebraic sum means with sign, because power of convex lens is always positive, and the power of concave lens, it is always negative. Remember dear. Okay, concave lens power negative, and the power of the convex lens, it is always positive. So dear friends, this is about the theoretical portion of this chapter. Thank you very much.